So I explained it this morning in class. We need to complete the discussion on this problem from lecture 6 part 2. So that's what we're going to do now, and we're also going to complete the lecture material for this particular topic. So in the previous video we saw how to do steps 1 through 5. So once we have identified and determined the coefficients of utilization, we can move to the next steps. So step number 6 will be to determine the light loss factor. Since we are using fluorescent lamps in uncovered fixtures in a medium dirty environment that are cleaned every 24 months, a lamp luminary dirt depreciation factor of 0.85 may be obtained for table 7 from the slides. Therefore, the LLF is 0.85. So using this data, all the data that we have compiled until this point, we can go to step 7, which is calculating the number of lamps and luminaries. So according to equation 4 in this lecture, the number of lamps requires, if 60 watt fluorescent lamps are used, is 179. So that's after substituting the numbers into equation 4. From here, we can move to life safety systems, which is the last piece of this lecture. Life safety systems are designed to control emergency situations that will disrupt normal operations. These emergencies are created primarily by fire, seismic events, power failure. So fire is the most pervasive of the three and accounts for the majority of costs associated with disaster. Fire resistance is therefore critical in the design of any facility. In terms of fire protection and safety, the first objective of the facilities planner is to determine the building's function and construction type as defined by the occupancy classification. So these occupancy classifications are based on the International Building Code, and they are listed here in table. So we have different groups, we have different letter classifications, and then the type. The type of structure also governs the degree of fire resistance. Fire resistance, therefore, refers to the ability of a structure to act as a barrier that will not allow the fire to spread from its point of origin. So there's no such thing as a fire immune building. Facilities planner must be cognizant of the need to provide for safety routes and an integral part of the layout. So most building will require 2 or more exits. Most local building codes will require that maximum allowable time or distance to exit the building not to be violated. So no point can be more than 200 feet from the exit. 200 feet, 250 feet in a building with sprinkles, and up to 400 feet in a building with early suppression, fast response, fire protection, and automatic smoke and heat vents. You see, depending on the type of system that you have available in the facility, then you have to plan for the location of the exits and how far are they from every employee and every point in the facility. So here we have the IVC table for maximum floor area allowance per occupant. So depending again in terms of the type of industry that you are in, you see we start with the used agricultural building. The floor area per occupant feet square is about 300 gross. Aircraft hangars 500 gross, and as you move down, there's multiple industries here and different type of floor area that should be allowed. Table 9.12 is the minimum number of exits for occupant load. So if you have 500 or less, you should have minimum of 2 exits. You have between 501 and 1000, you have a minimum of 3, and over 1000 you should have 4. In terms of the remoteness requirements, that's table 9.13. Two exits of exit access doorways, where two exits of exit access doorways are required from any point of the exit access. The exit doors or exit access doorways shall be placed a distance apart equal to not less than 1/2 of the length of the maximum overall diagonal dimension of the building or area to serve measure in a straight line between exit doors or exit access doorways. Interlocking or scissor stairs shall be counted as one exit stairway. And that's the end of this lecture. Thank you.